So the first one should be easy, hopefully. This guy is very much like what we did yesterday. Where are we going to start? 5. Which 5? On the y-axis. Positive 5 on the y-axis, my y-intercept. So starting at the point 0, 5. How do I find my next point? Down one, right one. Down one, right one. Down one, right one, like this. Ooh, hopes I actually hit the dot. So whenever we have a negative slope, it should look like it's going downhill. There we go. I'm good at words. We're going to use our ruler because that is really important. Ooh, I'm so good at lines, even with rulers. All right, hopefully that one was not too hard. What about the next one, where we have this x equals 5? What's that going to look like? Say it again. 5 on the x-axis. My x's are 5. They can only be 5. They cannot be anything else. So my x is going to be here. And I'm also going to have here. And here. And here. My x is stuck at 5. It can never go left to 4. It can never go right to 6. It is stuck at 5. So this is a vertical line through x as 5. So it's been a hot minute since we saw a vertical or horizontal line. But it's really important that we see those every now and then. So it should look like that. I don't know why I made the blue one so much skinnier, but I sure did. Okay. Questions about either one of those? Because what we're going to do today is we're going to make pictures very much like this today, and I'm going to ask you one additional question. Where do they cross? At 5, 0. That is what we are doing today as our lesson. We're going to graph 2 lines and figure out where they cross. Okay? So, tomorrow we're going to start doing it where we don't graph them and still finding where they cross. But we're going to start with that because we're familiar with graphs and we can see what's happening and we know what's going on. So since we are making a series of graphs, very much like yesterday, how I made your worksheet. For your notes. Okay? If you would prefer to write things by hand, totally fine. But this has the problems, has the length recruited in, etc., etc., etc. So we're going to be talking about systems of equations. That's what the meat of this chapter is all about, is systems of equations. So we're going to start by figuring out what the heck a system of equations is. Because we're going to have a lot of different methods to solve systems of equations. And my little number line just keeps falling down. No. All right. So when I say a system of equations, what that means is we're going to be given a set. Ooh, I don't like how chunky that is. Hang on a second. I'm going to rewrite that. There we go. Of 2 or more equations that have the same variables. So they're all going to have x and y, or they're all going to have a, b, and c, or they're all going to have x, y, and z. But I won't have one equation that has a, b, and another one that has x and y, and say, look at those two together. So they got to have the same letters, but it's going to be two or more equations. Most of the time we're going to see it with two. We're going to have a couple of days where we see three equations, but it's not super common. And what we're going to be doing is we're going to be finding solutions. And what our solutions are, just like when we were finding our solutions for x equals or y equals kinds of equations, they are values that make the equations true. That is in general what a solution is. In particular with a system of equations, it's the ordered pair where they cross. It's the ordered pair where they cross. So it is super duper 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 extra important that when we are writing our solutions, we write them as an ordered pair. When we're looking at systems of equations, our solution is not going to be x is 2. X is 2 doesn't tell me a whole lot. I need an ordered pair, x comma y, every time. So what we're going to be doing today is we're going to be solving systems of equations by graphing, which is 100% exactly what we did in the bell work. We're going to graph our two lines and see where they cross. This is where it is ultra super duper extra important. We use rulers and we plot our points carefully. So let's do our first one. So we've got our 3x minus y equals 4 and 2x plus y equals negative 9. Okay, make sure I have the same graph you guys did. So we need to graph both of these equations to try and find our solutions. So if I look at the top one, 3x minus y equals 4, what can we do to graph this? If I have my 3x minus y equals 4. We can do x and y intercepts. One of them's going to wind up gross. We could try it, though. So if we do, for my x-intercepts, that happens when y is 0. So we're going to have 3 times x minus 0 equals 4. So what is x going to equal? Kind of eccidecimal. It's going to be 4/3. Which is really hard to put on the graph. So xy intercepts is a fine thing to check. We could get our y-intercept. That's not going to be awful. But if we're not getting really pretty numbers, what should we try instead? Yeah, let's put this in slope-intercept form. So we're getting, I'm just going to finish this line out, x equals 4/3, which I'm going to go, So instead, let's put this in slope-intercept form. So I'm going to have my 3x minus y equals 4. And I heard it over there. Our plan was to subtract 3x from both sides. So we have our minus y equals minus 3x plus 4. Then what? Divide by -1 to everybody. This guy by -1, this guy by -1, this guy by -1. Absolutely everybody. So we're going to have our y equals 3x minus 4. Which, while x and y intercepts would absolutely work, this is a lot easier to graph. So where am I going to start when graphing this line? At -4. How am I going to find my next point? Up 3. 1, 2, 3. Right 1. Up 3, right 1. Up 3, right 1. The more points you plot, the easier it is to connect them up accurately. I could even come down here and go down 3, left 1. Down 3, left 1. Again, the more points you use, the easier it is to plot them up. We're going to connect them up using our ruler. There we go. All right, make sure you go edge to edge on your graphs. Use your ruler, we should get a straight line. Very similar vibe on the next one. We need to plot this line too. I'm gonna do this one on the left. So we've got my 2x plus y equals -9. What are we gonna do here? Say it louder. Not just 2, subtract 2 to x. Yes. So I'm going to subtract 2x from both sides. So it's going to give me y equals minus 2x minus 9. I was going to say, and we're in slope-intercept form there. I don't even need to do anything else. So where am I going to start when I plot my line? -9, down here on my y-axis. How do I find my next point? Down to right 1 would absolutely work. Unfortunately, I do not have down 2 spaces that I can go. I can kind of guess it's going to be here-ish, but that's not super accurate. What else could I do? Up to left 1. So as long as I flip both, I can do that. Up to left 1, up to left 1. Ooh. Up to left 1, up to left 1. That's still giving me that downward slope. It still looks like it's going downhill or down a slide. Like that. Connect up our points using our ruler. And it should look something like that. All right, so then here's our big question of the day. Where is our solution? -1, -7. It's this point where they cross. This is why it's super important that we're accurate with our lines and accurate with our rulers. If our line goes wobbly the whole way down, it's going to make it really hard to read that. That's why I've been so particular about needing to use rulers. So our solution, which you guys actually have a line for, but I didn't give myself one. Our solution is the point -1, -7. So it's got to be written as an ordered pair. Gotta be, gotta be, gotta be. questions on the first one? Questions? Okay. Same vibe on the next one. So I've got 7x minus 3y equals negative 12. And 7x minus 3y equals 9. Where's the font change? I changed the thing. So very same vibe. I'm going to take this top one. My 7x minus 3y equals negative 12. What are we going to do here? What can we do here? Gorge. Subtract 7x from both sides. So I'm left with my minus 3y equals, and I can't combine these together, so I'm just going to squish this guy in front. I've got my minus 7x minus 12. Then what? Divide by that negative 3 to absolutely everybody. So those negative 3's cancel out, and we're left with our y equals. What does negative 7x divided by negative 3 simplify down to? Just 7/3. The numbers don't simplify, but the negatives cancel out. So I got my 7/3. How about negative 12 divided by negative 3? Plus 4, because the negative over a negative cancels out. That's how we got our positive 7/3. 7 divided by 3 would leave us with 2 1/3, which, while accurate, doesn't help us when it comes to graphing. Okay, we see it? All right, when we graph this one, where am I going to start? Positive 4 on my y-axis, this guy here. How am I going to find my next point?
Down 7 to 3.
We could go down 7 into the left 3. We could also go up 7 into the right. That does put us just barely off my screen, so it's going to, yeah. I was going to say, we normally go up and right, but if I go up 7, that puts me off the edge of my graph. So up and to the right, or we could go down and left. As long as I flip both, it still counts as a positive slope. So down 7, left 3, which should be here. Ooh, what's that? It's gonna freak out for a second because my app just crashed.
Oh, how far?
Well, I accidentally swiped out of the app, but there we go. Hey, there's not a newer instance of the app. Okay, now it's really freaking out. Do your thing, please. Get back to my stuff. Technology is so much fun, y'all. Oh my gosh.
I'm pretty sure I wouldn't have survived like that.
As someone who lived through the technology revolution, it was a very strange time. Yeah. To be fair, before social media, there was a lot less of that. Because I was there for the birth of Facebook. I was there for the birth and death of MySpace. I am old and therefore have seen many technologies come and go. My sister had a pager. All right, so here's our line. It looks very similar to that. We're going to do the very same thing for the other line. My 7x minus 3y equals 9. What do we notice about these two equations? They are very, very similar. We've got 7x and minus 3y on both of them. So we have very similar pieces here. I wonder what that means is going to happen with their lines. Their slope is going to be the same. I wonder what that means. Huh?
It's parallel.
All right, so we wind up with the same kind of process. We still want to get those x's away, so I'm going to subtract that 7x again to get our minus 3y equals our minus 7x plus 9. And again, it's the same process as on the other one. I need to get rid of that negative 3, so we're going to divide everybody by negative 3. So we're going to have our y equals what? What's our simplified equation here? 7/3 x minus 3. So where do I start graphing my green line here? Negative 3. And how do I find my next point? Up 7, right 3. The top is a 7. That is one of the things that also we need to, some of us need to be intentional with our handwriting, not saying everybody, and I'm saying me sometimes, absolutely. So what do we notice about these two lines? I probably could. Ooh, I'm so good at lines. We're gonna try that again. There we go. I'm going to make my purple line a little bit thicker just because it's really thin right now and it's hard to see sometimes. Whoops. I made things worse. There we go. What do we notice about these two lines? They're parallel. When we're looking at the equations of lines, how can we tell that they're parallel? What do they have that's the same? Their slopes are the same. So, where do they cross? They don't. Ever. That is one of those defining principles of parallel lines. Like train tracks do not cross because the train would go ka-thunk and turn into a cartoon and crash into itself. So there is no solution if you wind up with parallel lines. So, no solution because parallel. They do not cross. They never, ever, ever cross because they are parallel. We will see these occasionally show up on things like homework and quizzes and tests and stuff like that. We will probably see no solution. We have another kind of special case where essentially I give you the same equation twice. So we graph the lines and they wind up being the exact same line, and that's when we would have something like infinitely many solutions, which we've probably heard that phrase before, but it's been a minute. It's not super common. If you are getting no solution every single time, stop and check in because we should not be getting no solution every single time. More often than not, we're going to have a point because that would just be mean. Okay, questions on this one? The next ones are much easier. They're already in slope intercept form. Yay! So these ones will go a lot faster because we don't have to do very much solving for them at all. So we're going to graph both these lines just like we did in the bell work. Where am I going to start on this first line? -1. And how do I find my next point? Up 2, right 1. Up 2, right 1. We love it when they're in slope intercept form. It makes our life so easy. Or at least easier. I was like, when we're using our rulers, we're gonna like pin the ruler down, but then also don't have to draw with all our strength. Sometimes we're just like fighting our own self. All right, let's do the other one. Where am I gonna start with this guy? Positive 2. And how do I find my next point? Say it again. Up 1 over 2. Up 1, right 2. Up 1, right 2. Or I could go down 1, left 2. As long as I flip both, I can go whichever direction I darn well please. Sometimes we can look at it when we're at this point and say, oh, I can see where they're going to cross. I still want you to draw the dang line anyway. Mostly because y'all's points are sometimes very faint and I cannot see them because I am old. So where is our solution? Two, comma. I heard that part. 3. It's this guy right here. Where my lines cross. Chonky point. There should not be a ton of times that we get things like decimal answers. It can happen every now and then. But again, if you are getting decimal and fraction answers every single time, stop and check in. Because we're mean, but we're not that mean. I mean, we are math teachers. We have a certain amount of sick joy we get from torturing you. Just a little bit. Just a little. But only a little. Okay, one more set. Last set. So I've got my 2x plus 2 and 1/3 x minus 3. So on my top equation, my 2x plus 2, where am I going to start? Positive 2 on my y-axis up here. And y'all can start to see why we worked so hard on graphing yesterday and how much graphing we got on these. Oh my gosh. There we go. How do I find my next point? Up 2, right 1. Oh, and then I ran out of graph, so I'm also going to go down 2 and left 1. The more points you have, the easier it is to get your line to be straight and accurate. If I just have 2 little bitty dots close together, it is really hard to get those angles correctly. So, if the more dots you have, the easier it is. There we go. All right. Last one for us to do together up here. Where am I going to start on this blue one? -3 on my y-axis. How do I find my next point? Up 1, right 3. Up 1, right 3, which I'm off my graph a little bit there. I could also go down 1, left 3. I'm going to use this moment to prove us this was a point. This is why I was always telling us when we were graphing to make sure we go to the edge of our graphs. Because if I just did this, it's a lot harder to tell where they cross. This is why we don't do baby lines and you go from edge to edge. Because that's a lot harder to read. So we need to make sure we go from edge of graph to edge of graph as far as our line will let us. Because then we can actually read where it's going to cross instead of trying to guess where it's going to cross. I promise there's reasons when I'm petty about something. I promise there's reasons. I don't do it just to be mean. It's more work for me. So where is our solution? -3, -4. The point. -3, comma, -4. Okay, so we write them as points. We have to write them as points. It is super duper important. Okay? Questions? All right. So we have more than 10 minutes left. Ooh. That's an update. I didn't see that on there. Why did you cross out number 11? Somebody else put that in there. Oh. Okay, yeah, I support it. You do number 11 if you want. But you don't have to do number 11. Okay, I didn't write that in there. Somebody else did. So number 11 is probably mostly because no matter what you do, you're going to wind up with a correct answer point. So this is the first homework we've had since we went back. You can do absolutely everything on here. So technically, I think I always give you guys at least a day of grace anyway. What's up? I'm still good at counting. Oh. I kind of figured you'd be able to do that, dude. Okay, so you guys can work on this, ask questions, whatever you need to do, all that jazz.
One of it is so confusing. We had, so on our way to Phoenix, we had a layover